Alright students, let's look at this question here, which is an interesting one from the topic of polynomial. Let's see how I can do this proficiently. So you're given that the polynomial fx of degree 3 leaves a remainder of 10 when divided by x minus 2. So this case here, we would know that by the remainder theorem, that this will be f2 is equals to 10. That's the very first thing that we must be able to tell. And negative 15 when divided by x plus 3. So the second statement tells us that when basically f, if you were to change this is f negative 3 equals to negative 15. Okay, that's great. Now take note, this is a degree of 3. Degree of 3 just means that this polynomial here, fx, is some form where this is like ax cubed plus bx squared plus cx plus d. Okay, now the next question they ask is what would the remainder be when it's divided by x squared plus x minus 6. Okay, so in other words, if fx is in the degree of 3, if I were to divide this by x squared plus x minus 6, I know that what would happen is essentially because this will be a polynomial here, quotient. This is what we call quotient, right? You leave a quotient here regardless. Okay, a quotient here. And after it, what we will get from this side here is you will get x squared plus x minus 6 as well as a divisor, and you have a remainder here. Now this remainder, just like when we say 7 divided by 2, this is 3 over 6 over 1. So typically what I'll tell the students is just remember that it's the same thing. You have a quotient, remainder, and the divisor. Okay. Now, but in polynomial, just remember the height, it will not exceed the degree of the divisor. Okay, just like here, when you look at this divisor is 2, this number on top remainder will never be, this remainder here will never be more than 2. Okay, so in the same sense, the remainder will never be a higher degree than the denominator, the divisor. So what we'll get is actually ax plus b. Right, and when we don't really need to worry about this px here, it will settle by itself. So this is what you should be able to tell when divide by this. What we want to find is actually what is this remainder here. This is what you need to find. Okay, so that's what we need to find. So clear. Then what we need to then do is actually try and understand this. So I'm going to cross multiply both sides with x squared plus x minus 6. Okay, so fx, just multiply both sides by x squared minus x minus 6, and this will give us px, x squared plus x minus 6, and this will just be ax plus b. Then what we need next is to understand how do we use the previous information to actually solve this question here. Take note that x squared plus x minus 6 is actually equals to x minus 2. When you factorize it, it will be x minus 2 multiplied by x plus 3. Okay, so that's very convenient, because then what we can do is actually fx equals to px. We just factorize this x plus 2, x minus 3. X minus 2, x plus 3, x minus 2, x plus 3. And this will give us ax plus b. Okay, so I think the main thing is to know that this is a degree lower. Maximally, it will be a degree lower. Okay, it will never exceed the degree of the divisor. I think that's usually the key point where students don't understand. This is the point where if student finds it difficult. But it's a very fundamental concept which you have to know. Okay. So this part here, you just have to take note. Now, once done, we are fine. Then what we could do is actually, we know that f2 is equals to 10. So you just replace this as 2. So f2 will just be p2, x equals to 2 here, right? And x, that's the reason why this whole thing will become 0, because we don't really care what is the px there. But we know that anything multiplied by 2, by 0, will just be 0. So this is 0, right? This thing here is 0, so this whole thing will just reduce, just disappear, become 0, and what we have is f2 as 10 equals to 0 plus 2a plus b. Actually, what we could do is just write this as 2a plus b. Let me just write this whole thing at 0. Okay, so you do the same thing for the f negative 3. So we'll replace negative 3 in. So f negative 3 equals to a negative 15. This will just be f negative 3 equals to p negative 3. So just replace into this. So it's negative 3 minus 2, then negative 3 plus 3, which is 0, plus negative 3 a, which is negative 3 a plus b. And that will give us negative 15, right? Negative 15 equals to negative 3a plus b. So we have the equation number 1, and simultaneously we can solve this. What I'm going to do is just take a 2, it may be 1 minus 2, that will give us 10 minus 15, 2a plus b minus negative 3a plus b, and that will give us 5a. Yeah, 5a, then there will be 25, alright, 25. So a will just be 5. Okay, then what we're going to do is just replace this in to this equation here. So 10 equals to 2 times 5. 2 times 5 plus b. So this will give us b equals to 0. So hence, a equals to 5, b equals to 0. The remainder, now remember, so let's just write this down. We want to find the remainder. Ax plus b. Remainder ax plus b, so this will just be 5x. Okay, so that's how we do this question proficiently. If you have any questions or comments at all, please let me know, and I'll see you in the next question.